From fallen storm timber to precision-cut boards, this is where raw wood meets serious machinery. Watch excavators de-lean with surgical control, cable systems conquer steep terrain, and automated lines turn rough logs into clean, ready products. Every cut, every movement, engineered for speed, safety, and efficiency. This is modern timber processing: power, precision, and productivity in action. The Komatsu PC2000 paired with the ProPac 453 delimber, turns raw forest timber into a controlled flowing operation. There's an unmistakable rhythm as the machine guides each log into position, the boom moving with calm precision while the grapple locks in like a statement of intent. That brief grab before the cut feels deliberate, power held in check, before branches are stripped away in a single, fluid motion. What stands out isn't just speed, but confidence. Logs glide through the delimbing heads with consistency, no hesitation, no wasted movement. Rough, uneven timber is transformed almost instantly, reshaped into clean, fuel-ready sections that stack up faster than the eye can follow. It's a process that looks effortless, yet carries the weight of serious engineering behind every movement. The ProPac 453 adapts seamlessly to varying log sizes, maintaining steady throughput without slowing the flow of work. Beneath it all, the PC2000's stable chassis keeps the entire operation grounded, even on challenging forest terrain. Together, they deliver a balance of strength, control, and efficiency that keeps production moving and downtime to a minimum, proving that modern forestry is as much about precision as it is about power. Fallen trees lie scattered across the Multiple Valley, silent evidence of storms that swept through content and reshaped the forest in a matter of hours. What remains is a complex landscape of tangled trunks and broken crowns, waiting to be recovered with care. In terrain this steep and unforgiving, efficiency alone isn't enough. Control is everything. The Synchro system brings order to the chaos, initiating a controlled downhill extraction that feels almost measured against the raw force of gravity. Logs begin their descent under constant tension, guided rather than dragged, as operators balance speed with restraint. On slopes where footing is uncertain and mistakes carry consequences, the system keeps each movement deliberate and predictable. Stormwood is never uniform. Twisted fibers, uneven weight, and heavy, jagged branches demand constant attention from both machines and crew. Operators read the terrain and the timber at the same time, adjusting their approach as each log reveals its own challenges. Some trunks are trimmed where they lie, shaped just enough to ensure a cleaner, safer journey downhill, reducing sudden shifts that could stress the rigging or the cable itself. As logs move downslope, they pass through intermediate holding areas, quiet pauses in motion where momentum is managed and the flow is regulated. These collection points keep the operation balanced, preventing congestion while allowing crews to adapt to changing conditions. Occasionally, a log reacts unpredictably, bouncing or rolling slightly along the slope, adding tension to an already dynamic environment. Every adjustment matters. At the collection area below, the forest's raw material begins to take on structure again. Logs are sorted by size and purpose, smaller pieces set aside for firewood, larger trunks prepared for their next journey to sawmills. Each piece is tagged and documented, maintaining a clear record from mountainside to processing facility. Throughout the operation, safety remains ever-present. Protective gear, radio communication, and constant coordination form an invisible framework supporting the visible work. The Synchro system allows crews to clear storm-damaged timber efficiently while minimizing soil disturbance and preserving the fragile alpine terrain. In the end, this workflow is more than extraction. It's a balance of technology, experience, and respect for the environment. Proof that even in the aftermath of destruction, careful coordination can restore order and value to the forest. Logs enter the DDL processing line and are immediately brought under control, scanned, and aligned with quiet precision. Automated rollers guide each piece forward while operators watch closely, reading the flow of the material as much as the data on their screens. The movement is constant, but never rushed, with small adjustments made in real time to keep everything running smoothly. As the line advances, cutting stations reduce raw logs into clean, uniform sections. Blades move with confidence, adapting to subtle changes in grain and density that could otherwise disrupt the rhythm of production. Each cut reveals the character of the wood, and trained eyes catch imperfections early, ensuring only consistent material continues down the line. Conveyors carry the processed wood onward without hesitation, eliminating bottlenecks and wasted motion. Behind the automation, human oversight remains essential, fine-tuning feed rates and responses to maintain quality. The result is a steady output of uniform, high-grade wood, ready for drying, storage, or the next stage of processing. On the Diametra No.10 line, cutting units bring raw timber under immediate control, trimming each piece to exact lengths required for uniform pallet production. There's a steady confidence in the way boards are introduced to the system, operators working in sync with the feeding line to keep everything flowing without hesitation. Even at speed, the process feels measured, built around precision rather than brute force. The cutting units work with remarkable consistency, shaping timber to specification without interrupting throughput. Each board moves forward seamlessly, passing into sanding stations where rough surfaces are refined and prepared for assembly. Subtle vibrations fade as clean, even faces emerge, revealing wood that's ready for industrial use. Throughout the line, sensors quietly track board positions, maintaining alignment and preventing costly misfeeds. Quality checks are woven into the process, catching dimensional errors or surface flaws early, long before they can compound into waste. The system adapts easily, handling multiple board sizes at once and maintaining output even as specifications change. At the end of the line, stacking units take over, organizing finished boards into clean, stable piles that simplify handling and storage. After inspection, boards are bundled and prepared for shipment or the next phase of processing. Operators remain attentive, making fine adjustments to feed speeds and machine settings as conditions shift. The result is a production line that balances speed with control. Mechanical precision and human oversight work together to deliver durable, consistent pallet components, minimizing waste while maximizing efficiency. That final trimming action, sharp, fast, and exact, underscores just how refined this high-throughput operation really is. Logs are carefully positioned on the Boldrew TYPA 1200, where the focus immediately shifts to balance, control, and consistency. Despite its compact footprint, the machine is built to handle serious timber, accommodating logs from 1,000 to 4, 200 millimeters in length, and up to a full meter in diameter. It's a setup that doesn't demand uniformity from the wood, but instead adapts to whatever the forest delivers. Each log settles onto adjustable support arms that are fine-tuned by operators to maintain stability throughout the cut. There's a quiet confidence in the way the system holds heavy material in place, allowing the cutting process to remain smooth and predictable. Hydraulic tensioning keeps the bandsaw blade perfectly aligned, reducing vibration and extending blade life even during extended runs. Power comes steadily from the main 7.5 kilowatt drive motor, pushing the 4 800mm saw blade through timber with controlled force rather than brute aggression. Feed rates remain consistent, avoiding strain while maintaining momentum. For heavier logs or longer operating periods, additional 11 kilowatt or diesel-powered motors step in, ensuring performance never falters when the workload increases. Operators retain full control, lifting the saw head electrically or managing feed manually when precision takes priority. Rollers and leveling systems work beneath the surface, keeping logs aligned and minimizing deviation as each cut progresses. The chain turner and hydraulically extendable supports rotate even massive logs with ease, positioning them accurately without excessive handling. Advanced accessories further refine the workflow. Cutting thickness readers and electric roller positioning reduce guesswork, allowing adjustments to happen seamlessly and quickly. Logs pass through bark trimming and end cutting stages, emerging cleaner and more uniform, ready for stacking or transport. Multiple logs can be managed within the same workflow, keeping throughput high while reducing operator fatigue. Every cut is watched closely, not out of concern, but out of respect for consistency. Mechanical coordination and smart control come together here, delivering reliable output from a surprisingly compact system. Watching it handle timber of this size so efficiently, it's hard not to be impressed by just how much capability is packed into the Boldrew TYPA 1200. Safety takes the front seat in every session at Underwriter's winch training courses, where real equipment and real conditions shape the learning experience. Guided by experienced technicians, participants work directly with cable winches, discovering how even familiar maneuvers demand focus and respect. Movements that appear simple can quickly become unpredictable if handled carelessly, and the training makes those risks visible before they turn into accidents. Through controlled lifts and precise tensioning, operators build confidence while sharpening their instincts. It's hands-on, practical, and immediately useful, proof that effective training goes far beyond theory. West Fraser's LVL plant operates with a clear priority: organizing logs in a way that extracts the maximum possible veneer while maintaining consistency and efficiency throughout the operation. From the very beginning, the process balances experienced human judgment with advanced automation, ensuring that every decision made upstream supports smooth production downstream. Logs arrive at the West Fraser yard already identified and clearly marked, allowing crews to sort them quickly based on species, diameter, and expected veneer yield. This early classification plays a critical role in maintaining steady production flow and preventing congestion later in the process. Each log undergoes careful evaluation to confirm it meets strict quality requirements. Factors such as straightness, surface condition, and internal integrity are considered, as even small defects can reduce veneer recovery. Yard crews rely on heavy machinery to move logs into position for the bucking station, but every movement is calculated. Avoiding unnecessary handling not only saves time but also preserves log quality. Operators work closely with digital measuring systems, confirming dimensions and alignment to ensure cuts are accurate and veneer yield is maximized. Even the smallest misalignment can affect downstream processes, so concentration remains constant. Safety protocols are seamlessly integrated into this phase, keeping workers clear of moving equipment while allowing log placement to remain efficient and controlled. At the bucking station, logs are cross-cut into billets specifically sized for veneer production. This transition marks the shift from raw material handling to precision processing. Saw operators coordinate closely with conveyor systems, ensuring each billet moves smoothly toward the soaking vats without interruption. Before soaking, technicians visually inspect every billet, identifying defects such as cracks, rot, or grain irregularities that could weaken the final LVL product. This inspection step acts as a quality filter, preventing compromised material from advancing further into the system. The soaking vats represent a critical transformation stage. Billets are submerged in carefully controlled solutions designed to soften the wood uniformly, allowing for clean and consistent slicing. Variables such as temperature, immersion time, and pH levels are continuously monitored to maintain stable conditions. Seasonal changes in wood moisture require ongoing adjustments, ensuring billets behave predictably during slicing. The soaking process penetrates deeply into the wood fibers, reducing internal stress, minimizing splitting, and improving veneer surface quality. Quality control teams regularly sample billets throughout the day, fine-tuning vat conditions to compensate for natural variations in species and density. Specialized sensors record detailed soaking data for each batch, creating a complete processing history that supports traceability and quality assurance. Once soaking is complete, billets move into the roundup area, where precise alignment becomes essential. Rollers and conveyors position each billet carefully for the spindleless lathe, ensuring smooth feeding and consistent veneer thickness. Proper alignment here directly affects structural performance, making this stage particularly critical. The spindleless lathe rotates billets while precision blades continuously peel thin veneer sheets in a controlled, uninterrupted motion. Operators monitor feed rates and blade angles constantly, adjusting settings to accommodate differences in wood species or internal density. Veneer thickness is measured at regular intervals to ensure it remains within tight engineering tolerances. Immediately after slicing, veneer sheets are visually inspected for defects, allowing operators to intervene early if quality begins to drift. Clipper machines trim the edges to precise standard widths, producing uniform sheets ready for lamination. This edge consistency prevents gaps during pressing, preserving the strength and reliability of finished LVL beams. Any edge trimmings are immediately diverted back into the plant's energy system, reinforcing the facility's efficient use of resources. Stackers then take control, organizing veneer sheets into uniform, carefully arranged bundles. Automated random pulling and stacking systems distribute sheets by size, grade, and moisture content, keeping the workflow balanced and efficient. The system calculates optimal stacking patterns to minimize handling while reducing the risk of damage. Operators monitor stack uniformity closely, logging any anomalies to support continuous improvement. Offcuts and waste material are routed to the chipper, where they are converted into wood chips used to fuel the plant's energy system. This transformation of waste into usable energy minimizes disposal and strengthens sustainability efforts. The pointer daumer machine shapes beams to precise angles, ensuring they align perfectly during lamination. Operators constantly verify dimensions and adjust guides, preventing cumulative errors that could affect structural integrity. Beam angles are digitally recorded, allowing full traceability and supporting rigorous quality standards. The hog and energy plant operates continuously in the background, consuming bark, chips, and residual wood to generate heat and electricity for the facility. This closed-loop energy system significantly reduces reliance on external power sources while lowering operating costs. Dryer systems then remove moisture from veneer sheets, targeting exact moisture levels required for pressing. Technicians monitor airflow, temperature, and drying duration closely, knowing that even minor deviations can lead to warping or weakened bonds. Density and moisture sorting equipment follows, separating sheets to ensure uniform performance. Sheets outside acceptable limits are rerouted for reprocessing, ensuring only high-quality material advances. Pressing represents one of the most critical stages in LVL production. Veneer sheets are coated with adhesive and assembled into presses, where pressure, temperature, and cycle time are precisely controlled. Each beam size requires specific settings to achieve uniform bonding and structural reliability. Finished beams and headers undergo inspection before leaving the press line, as even small adhesive errors can compromise load-bearing performance. Adhesive mixing ratios are checked repeatedly to maintain consistency. After pressing, beams move into finishing. Automated sanding machines smooth surfaces and remove imperfections, preparing the material for coating. Proper sanding improves both appearance and coating adhesion. In the coating station, protective finishes are applied evenly, enhancing moisture resistance and durability. Operators monitor curing conditions carefully to prevent defects such as bubbles or streaking. Each batch is marked with a production code, maintaining full traceability. Finally, stackers organize finished beams for storage or shipment. Climate-controlled storage protects coatings and prevents warping. Shipping teams coordinate deliveries efficiently, aligning production output with customer demand. Throughout the process, the energy plant continues converting byproducts into power, completing the resource loop. West Fraser's LVL operation brings together log selection, bucking, soaking, slicing, drying, sorting, pressing, finishing, and stacking into a unified, highly efficient system. Automation and skilled human oversight work together to deliver consistent, high-quality engineered lumber. The finished LVL beams are reliable, durable, and ready for demanding structural applications, reflecting innovation, discipline, and expertise at every stage of production. The AMR Quattromat moves through its calibration cycle at Quattromat with quiet confidence, cutting wood in smooth, consistent strokes that reflect careful engineering. As the system runs, cut lengths shift effortlessly between 25 and 50 centimeters, adapting without breaking rhythm. Operators fine-tune the feed system and rotation speeds, watching closely as each pass delivers uniform results. Every movement is designed for efficiency, reducing waste, while maintaining a steady, reliable output that keeps production flowing without interruption. The automatic log bagging line moves with a steady sense of momentum as logs are guided onto the conveyor, each piece flowing naturally into the system. Sorting mechanisms quietly separate logs by size, while rotating cleaning brushes strip away loose bark and surface debris, preparing them for clean, consistent packaging. Everything happens in motion, without hesitation, as alignment arms make small, precise corrections to position each log perfectly for stacking. As the line advances, bags and nets are already in place, waiting to receive logs cut to 20, 25, or 33 centimeters. The system adapts effortlessly, shifting between sizes without interrupting the rhythm of production. Operators watch feed speeds closely, maintaining a pace of up to 1 log per second, while preventing jams or uneven loading. That balance between speed and control keeps the entire process smooth. Inside the packaging chambers, logs are stacked cleanly before bags or nets are filled and sealed in one continuous cycle. It's impressive how a single chamber handles such a wide range of log sizes without sacrificing consistency. The motion never feels rushed, yet output remains high, minimizing idle time and unnecessary stops. Finished packages emerge ready for shipment, showing how smart automation can maximize productivity while significantly reducing physical strain on workers. Each log processed by the King M1418 arrives with its own character, yet the machine handles them all with the same calm authority. Diameters up to 18 inches move through the system without hesitation, the feed mechanism adapting instantly as each log enters the line. There's no pause for recalibration. Logs are measured, positioned, and advanced automatically, keeping the workflow uninterrupted and efficient. Hydraulic pressure shifts continuously in the background, responding to changes in density and shape to maintain uniform splits. When the splitting wedge descends, it does so with controlled, deliberate force, cleaving the wood cleanly into fire-ready pieces. Conveyor belts carry material smoothly through the hydraulic splitter, while operators make subtle adjustments to stroke length, ensuring consistency even as log sizes vary from one piece to the next. Cutting speed remains balanced across both softwoods and dense hardwoods. The saw blade spins with steady efficiency, slicing through tougher material with ease and leaving clean, predictable cuts. As logs move through the system, they slide into the collection area and stack neatly, guided to prevent jams or uneven buildup. Hydraulic arms assist with heavier pieces, keeping processing speed consistent and eliminating sudden slowdowns. Throughout the operation, safety remains clearly built into the design. Guards keep operators well clear of moving components, while intuitive controls allow fine adjustments to cutting angles, feed rates, and cycle timing. The machine's cycle time stays tight, feeding, cutting, and splitting in continuous succession without sacrificing accuracy. Even awkward or irregular logs are handled without drama. Pieces that might stall a manual operation are repositioned automatically and processed without stopping the line. The stacking pattern maximizes bin capacity, making full use of available space and reducing the need for constant unloading. Operators monitor the flow rather than fighting it, ensuring throughput stays high and consistent. Automatic adjustments dramatically reduce physical strain, shifting the operator's role from heavy labor to oversight and fine control. The result is a process that feels almost effortless, even as it handles demanding workloads. Once split, the firewood pieces are ready for packaging or immediate use. Conveyor extensions and chutes direct material efficiently into bins or storage areas, keeping the site organized and productive. The King M1418 transforms what was once exhausting manual work into a safe, reliable, high-output operation. Watching it run, it's hard not to rethink traditional firewood processing. This machine handles volume, variation, and precision all at once without constant intervention. Powerful logs are fed into the Spaltfix K350 firewood processor, where pieces up to 35 centimeters are handled with ease. As each log enters the system, the cutting unit adapts automatically to changes in diameter, delivering clean, consistent slices without slowing the workflow. The splitting wedge follows with controlled, steady force, breaking the wood into evenly sized firewood ready for use. Conveyor systems move the processed pieces smoothly toward collection or stacking areas, keeping material flowing without interruption. Operators fine-tune stroke length and cutting angles to match differences in wood density, ensuring reliable performance across both softwood and hardwood. A post-cleaning unit removes loose bark and debris along the way, leaving firewood clean and presentable for packaging or immediate use. Even irregular or challenging logs are processed without disrupting throughput. Stacking mechanisms organize the finished firewood efficiently, maximizing bin capacity while eliminating the need for manual handling. The result is a fast, consistent, and well-controlled operation that turns heavy timber into ready-to-use firewood with minimal effort. Wood and biomass flow into the Vermeer HG6800TX chip drum, a system built to handle everything from fine playground chips to heavy paper mill residues. As material enters the drum, adjustments are made to control chip size with precision, allowing the output to match the exact needs of each application. Operators balance feed rate and drum speed carefully, responding to changes in material density to keep the process stable and efficient. Inside the drum, hardened blades shear and cut with consistent force, breaking down wood and biomass into uniform chips. Screens guide material through the system, filtering out oversized pieces and ensuring only correctly sized chips move forward. Conveyors carry the finished product smoothly into storage piles or downstream processing lines. Even wet or tough biomass passes through without clogging, keeping production steady and reliable throughout extended runs. Built for dense wood, the Titan 23T branch shredder drives a powerful rotor through dry logs up to 105 millimeters with confident force. Material feeds steadily as operators maintain a smooth rhythm, while adjustable counter knives keep each cut clean and consistent. Boosted ventilation clears chips quickly from the chamber, preventing buildup and keeping output flowing. Its compact width makes a real difference on tight job sites, saving space every day without sacrificing performance. The 1XP proves its strength in large tree operations, delivering consistent chip quality even under demanding conditions. Driven by a Cummins 275 horsepower turbo diesel, it takes on heavy timber without hesitation, maintaining power and momentum throughout the cycle. Logs are fed steadily as the rotor engages, breaking solid wood down into uniform chips suited for mulch or biomass applications. Operators have full control over feed rates and chip size, making it easy to adapt to massive crane-fed loads without disrupting the flow. Even the toughest Australian hardwoods are processed continuously, showing no signs of strain. Safety guards surround the working area, protecting the crew while still allowing high throughput. Watching it chew through timber this dense, it's hard to believe the machine never misses a beat. Designed specifically for tractor-powered forestry work, the RABAUD Xylochip 200T brings steady, predictable control to mixed timber chipping in real field conditions. Mounted behind tractors ranging from 75 to 140 horsepower, the machine integrates smoothly into everyday operations, drawing power without placing unnecessary strain on the drivetrain. Material feeds through a reinforced hopper built to handle irregular loads where branches and limbs rarely arrive in neat bundles. That wide intake immediately saves time, reducing the need for constant repositioning. Inside the machine, the rotor engages timber up to 20 centimeters in diameter, maintaining consistent chip size even as material density changes. Adjustable settings allow output to be tuned for different production goals, whether clearing, biomass preparation, or general forestry work. The pace never feels rushed. Instead, the workload remains controlled and balanced, giving operators confidence that the system will respond predictably. Feed rollers apply even pressure as limbs advance, preventing sudden surges or stalls. Cutting elements break wood cleanly, limiting splintering and irregular fragments. Uniform chips matter later, not just for appearance, but for efficient storage, transport, and downstream handling. The discharge chute directs material precisely, keeping the working area organized and free of unnecessary buildup. Operators can adjust chute angles and output direction on the fly without interrupting throughput. That flexibility keeps the tractor moving instead of waiting. With its 5-in-1 configuration, the XYLO CHIP200T adapts easily across tasks, delivering continuous, reliable performance. There are no surprise pauses, just steady progress, showing how tractor-driven chipping remains dependable in everyday forestry work.